The Royal Navy's dockyard at Portsmouth, a restricted area, but we have permission to be here, and so do you. So come aboard. We are DCP, Dawson Construction Plants, and we have something to show you. Here with a backdrop of Royal Navy and NATO warships is the dockyard's number 2 basin. During 1988, work was carried out to repair and improve the existing dock. The main contractor was Harbour and General Works. DCP were commissioned to supply their unique pile capping technique. This is the Red Ebb multi-pile soffit panel system, which enables construction of concrete capping up to 1 metre wide by up to 2 metres high. Traditionally, the job of capping or coping piles has been slow, expensive, and physically awkward. But that was before the invention of an ingenious system which makes this stage of construction work simple, fast, and cost-effective. Take a look at it in diagram. The system is comprised of Red Ebb brackets fixed into the pan of the sheet piles. The bracket supports soffit shutter panels in which are located rectangular steel rods. The rods are adjusted to take up the exact shape of the piles. A concrete pour of at least 15 metres per day can be achieved to produce an attractive purpose-made cap and icing on the cake, between 2 and 3 times as fast as other methods. So how does it work in practice? Well, the old tedious business of welding or bolting brackets to the sheet piles is replaced by installing these quick-fix Red Ebb brackets. You can see the bracket fitting into the pan of the sheet piles. How it does so is an interesting factor in the simplicity of this system. We'll take a look at one being installed. Before each is fitted, a setting outline has been drawn and marked with a punch. A bracket is offered up into the pan of the sheet pile. This one design of bracket is standard to most Z and U-shaped piles. Now a known torque is applied. Hardened steel points bite into the sides of the piles. So this is most certainly not friction supported. But each bracket will take a safe working load of 2 metric tons. The bolt at the bottom enables levelling of the bracket if needed. This procedure continues until a bracket is correctly positioned in every alternate pan. The soffit shutter panels consist of rectangular stainless steel rods retained within a framework. They're as easily fitted as were the Red Ebb brackets. You won't need special skills or even special tools. The old slow method of cutting and fitting plywood is eliminated. So too is material wastage. In this new method, nothing is thrown away. The panel has been secured on the bracket, and you'll see the bars being pushed towards the sheet piles, starting from the deepest part of each pile. They deck out the soffit area, assuming the shape of the piles, working equally well with Z or U-shaped profiles, and even conforming to any distortion caused in the driving. The fast, infinitely variable system creates a tailor-made and cost-effective basis for concrete capping. Any gaps between the backstop and the rear end of the soffit panel can be secured by a wedge. In the pan itself, small gaps can be filled with mastic or denso tape to prevent loss of grout or concrete, but generally grout leakage is so small that filler isn't needed. With conventional side shuttering in place, the concrete pour is made. Here at Portsmouth, the 2-metre-high cap provides an attractive, clean-lined finish to the newly installed piling. But it does more than simply look good. Capping in this manner structurally secures the piles together. It gives a positive locking against interlock slip, an important feature on Larsen piles. Some 40 miles east along the coast at Shoreham, DCP equipment was employed in another jetty construction job. Red Ebb brackets and the multi-pile soffit panels were installed to provide some 400 linear meters of capping. That's approximately 1,300 wall feet in American terms. Working as they are here in an advancing tide, demonstrates the ability to install the system below water. It's a feature that, in the United States, has been found to be very cost-effective, especially in the Gulf of Mexico, where high humidity and salt content create a corrosive environment for steel piles. So they need to extend capping below low tide level. Pretty well impossible with the old way, but highly efficient with the new system. Another example. This is London's south bank of the Thames, where there is extensive riverside development. The long, curving sweep of sheet piling will be capped attractively using the red air bracket and soffit panel combination. This purpose-built system has revolutionized old and slow methods of capping piles. Its successful formula is based on the best of good engineering practice. Safe and simple to install. Cost-effective in labor. No material wastage and easily reusable. It provides not only the icing on the piling engineer's cake, but the added structural integrity to prolong the life of his sheet piling. Now that is good engineering.